Hello. In this video, we will complete several examples of solving logarithmic equations and inequalities, and we will do so without the use of a calculator. In order to do this, it is important to rewrite logarithms as exponentials. Let's take a look at the first example. With this common logarithm, I would first rewrite it as the exponential 10 to the power of negative 1 equals 2x. Then, by simplifying, we have 1/10 equals 2x. And finally, by dividing by 2 on both sides of the equation, we see the result 1/20. We should check our work by substituting back into the original equation. We see that our equation is correct. Therefore, we can be confident in our answer. In the next example, we would rewrite the logarithm as the exponential 2 squared equals 3x plus 1. Then use the reverse order of operations to isolate the variable and solve for x. We see that the answer is 1, and if we check our answer, we should see a true result. I feel confident with this answer. In the third example, you should notice the number 3 multiplying by the logarithm. We should move it first to isolate the logarithm so that we could rewrite the logarithm as an exponential. If the logarithm is not isolated, rewriting as an exponential would be more difficult. So we could divide both sides by 3, and we would be left with the logarithm equal to 0.5 or 1/2. 16 to the 1/2 power, you should recall, would be the same as the square root of 16, which is 4. Please try the next two examples on your own. Pause the video and resume playback in a moment to check your work. Solving inequalities is a very similar process with only a few exceptions. First, we must be careful to identify solutions that allow the argument of the logarithm to be positive. Secondly, we must switch the signs of the inequality when rewriting the logarithm as an exponential. So, in the first example, we should isolate the logarithm and rewrite as 10 to the power of 4 is less than x. Remember, we need to switch the direction of the inequality. Therefore, 10,000 is less than x, or in other words, x must be greater than 10,000. Before we commit to this as a final answer, please confirm that these numbers ensure the argument of the logarithm is positive. When x is greater than 10,000, then of course x is greater than 0. To check your answer, substitute values larger than 10,000 into the original equation and see if the result computes to a larger value than 8. In this case, I feel a calculator is permissible. For our next example, we would isolate the logarithm and rewrite as 3 squared is greater than x. Remember to switch the direction of the inequality. Therefore, 9 is greater than x, or in other words, x must be less than 9. Before we commit to this as a final answer, please confirm that these numbers ensure the argument of the logarithm is positive. By considering a number line, we see the only numbers that are greater than 0 and less than 9 satisfy the solution and keep the argument of the logarithm positive. So we would record our final answer this way. 0 is less than x, which is also less than 9. You should substitute values from this range into the inequality to check your work. In our final example, we don't need to isolate the logarithm first, but we do see that it should be rewritten as 8 to the 1/3 power is greater than or equal to 2x minus 1. Please note that 8 to the 1/3 power is the same as the cube root of 8, which is 2. So, when we add 1 to both sides and divide by 2 to isolate x, we see that 3/2 is greater than x. To obtain our final answer, we should verify the numbers that would make the argument of the logarithm positive. So 2x minus 1 is greater than 0. And x must be greater than 1/2. On a number line, we see all numbers greater than 1/2, and numbers that are less than or equal to 3/2 would satisfy the inequality. Don't forget to pick any number in this range to check your work. Good luck.